Hello and welcome to this section of the chemistry tutor. Here we're going to continue working our redox reaction problems. In this section we're going to balance another reaction in acidic solution, just getting a little more practice each time we do this. So what if we had the reaction that goes like this? Here we have a chromium ion with a charge of +3. Here we have some bismuth O3. This is an ion that has a -1 charge. And then we have chromium Cr2O7 with a charge of -2. And then we have bismuth with a charge of +3. So that's our reaction. And again, we're going to use the exact same process that we have used before, which is right here on the board. The first thing we want to see is it written as a net ionic equation? And it is, because you can see that everything is listed here is already a charged ion. So everything's already dissociated and broken down. So that is what we really want to see when we're looking for net ionic equations. So what I'm going to do is write step 1, just put a check mark to remind me that that's done. Now step 2 is to write as half reactions. So what we're going to do is say, all right, the chromium's obviously going to go with the chromium. The bismuth ion over here is going to go with the bismuth over here. So we're not balancing anything here. We are just writing it down. Cr3 plus is going to go to Cr2O7 to negative. That's one of these half reactions. And then we're going to have bismuth O3, that ion going to bismuth 3 plus. So step 2 is only writing the half reactions down. Not with any electron transfer or anything like that. Step 3. Now what we're going to do is we're going to balance all but hydrogen and oxygen. So we always balance everything except for the hydrogen and oxygen. So that means the bismuth and the chromium, we're going to go ahead and balance that. So we can do that here. We can see we have Cr3 plus goes to Cr2O7 to minus. So when we look at this guy, we have chromium and we have 2 chromiums here. So the way we balance is we put a 2 there. We ignore the oxygen because we're not dealing with oxygen in this step. Then we will have bismuth, like this ion, and it goes to this ion over here. And then we try to balance this, and we realize that that's already balanced. 1 bismuth, so we can just copy it on down. So step 3 is complete. We've balanced everything except for hydrogen and oxygen. Okay? You can see that as you kind of get into the groove with this, that the process just kind of naturally comes about because you do it enough times. Okay, you balance this, and you balance the oxygen, and then you balance the hydrogen, then you balance the charge, and then you just kind of get the hang of it after a while, but it takes several problems to get there. So step 4, after we have balanced everything except hydrogen and oxygen, we're going to balance the oxygen with H2O. So that's the very next step. So then we look at this. We know we're going to have to do something with the top one. So we do 2 Cr3 plus right here goes to Cr2O7 to negative. So here we have 7 oxygens over here. So in order to balance that, we need to place 7 waters, because now I have 7 oxygens here to balance these guys over here. Here in the second half reaction, I have bismuth O3 negative, bismuth 3 plus. So I have 3 oxygens over here. The way to balance that with water is I need to put 3 waters like that. So I've balanced the oxygen with water. That's all I was concerned about in that step. All right, let's go on over to the next board. And what we're going to do next is rewrite these half reactions. And the very next step is to balance the hydrogen. So that's step 5, is to balance the hydrogen with hydrogen ions. The reason we're doing that is because we're in acidic solution. All right, so let's go ahead and do that. So what we're going to do first is just recopy the reactions over. All I'm going to do is recopy the reactions over. So I have 7H2O plus 2 chromium 3 plus gives me Cr2O7, charge of -2. I'm just going to write the next one right now. Bi O3, charge -1, goes to bismuth, charge of +3 plus 3 waters. All I have done is recopy the half reactions from the previous step. I've done nothing else. So if you look at the top reaction, I have 14 hydrogens here, and I have none on the other side. So the way I balance that is I put 14 hydrogen ions. That's what I have available in this reaction to balance it. And then I look here, I have 6 hydrogens over here, I have nothing else. So the only way to balance that is 6 hydrogen ions on the left-hand side. All right, so we are done. We have balanced the hydrogens with hydrogen ions. Okay, so that was step 5. So let's look at step 6. So we balance the charge with electrons. So now what this means is that we look on the left and the right-hand side of the reaction, and we calculate the charge on the left and the right, and then we add electrons wherever we need. So let's write the first reaction down. 7H2O plus 2Cr3 plus Cr2O7 plus 14 hydrogen ions. Okay, so now I'm going to switch to red. Before I write the second half reaction, we're going to work with this guy. On the left-hand side, see, this water is neutral. It doesn't have any charge, so it's 0. These chromium ions have a charge of +3, but there's 2 of them. So this is basically a charge of +6 on the left-hand side. And then over here, what I have is there's a 1 in front of this chromium here, so there's a -2, so this is -2 plus 14, because of 14 positive ions here, is going to equal +12. So what I end up having is I have a charge of +6 on the left-hand side of the reaction and a +12 on the right-hand side of the reaction. If I were to add electrons, and only electrons, to balance this, how would I do it? Well, the electrons are going to add basically a negative charge, so it can only bring down these numbers. So what I'm going to end up doing is add it to the most positive side. So if I add it here, I'm going to add 6 electrons, because if you add 6 to here, then it'll bring it down to +6, and it'll match with the other 6 that I have. So I've brought this reaction into balance. All right. Now, we're going to write the second half reaction. What we have is 6 hydrogen ions plus BiO3 negative is Bi3 plus 3H2O. So what I like to do is write the reaction down again. I know it's a lot of writing. What I have here is I have +6, and here I have -1, so I end up with +5 on the left-hand side. Over here, this is a 0 for the water, so this is a +3. So if I want to bring these into balance, I can only add electrons. I'm going to add it to the most positive side. How many do I need to add here? All I need to add is 2 electrons, because that'll bring this down to 3, which will balance with what I have. Okay, so we have completed step 6. What we're doing is we're balancing the charge on the left and the right-hand side of each reaction by adding electrons. So everything's balanced there. But then we notice, okay, in this half reaction, I'm losing 6 electrons. In this half reaction, I'm gaining 2 electrons. Those two things are not balanced. You have to have loss and gain of electrons between the two half reactions equivalent, so that the oxidized part of the reaction and the reduced part of the reaction are basically gaining and losing the same number of electrons. So what I need to do is do a step 7. And step 7 is to balance the electron gain-loss. And we do that with the multiplication, and then we're going to also add the reactions. So basically I can multiply these reactions by whatever I need to bring them to match the electrons on both sides. I have 6 electrons here, I have 2 here, so if I multiply this second reaction by 3, then this will be 6 electrons, which will balance with that. So that's what I'm going to do. And because I have so many colors on the board, I'm going to switch colors at this point. What I'm going to do is write the first reaction down as is, because we're not altering that. So what I'm going to do is carry that down and say 7H2O plus 2 chromium 3 plus yields Cr2O72 minus plus 14 hydrogen ions plus 6 electrons. That's the first half reaction. I've done nothing at all to it. And then I'm going to take this guy and I'm going to multiply by 3. So this is a reminder to myself that I'm multiplying by 3. So 2 times 3 is 6 electrons plus 3 times 6 is 18 hydrogen ions. 3 right here, 3 BiO3 negative. And then one out on the other side, I have a 3 bismuth ions, charge of positive 3. 3 times 3 is 9 waters. All right, 9 waters. So that is basically the reaction here. And what I need to do after I've multiplied it, now I notice I've got 6 electrons over here, so the gain and the loss of the electrons are good now. So I'm going to draw a line, and I'm going to add these together, because that's kind of the whole point. We break the reactions apart, deal with all the balancing, and then we're putting them back together. It's just kind of a nice technique here. So what I'm going to have is, when I add the left-hand side, I'm going to have everything on the left-hand side of the arrows here. So it's going to be 7H2O plus 2 chromium 3 ions. That's it for this guy. Then I have the 6 electrons here. Then I have the 18 hydrogen ions here. Then I have the 3 bismuth O3 ions here. So that's everything on the left-hand side of both arrows. So I'm going to continue the reaction on the right-hand side here. I have Cr2O7 there. I have 14 hydrogen ions here. And then I have 6 electrons here. And then I have 3 bismuths here. And then I have 9 waters. So you see, this is a lot of stuff that I have here, right? But fortunately, we're almost done. Because see, this was step number 7. Step 8 is to cancel. And what I mean by cancel anything that you can, right? So the most obvious thing that we want to cancel, let me switch colors here, is the 6 electrons are going to cancel with the 6 electrons, because that was the whole point of what we did here. But we look at everything else. Now this is interesting. We have 7 waters on the left, but we have 9 waters on the right. 7 waters on the left, 9 waters on the right. How many waters can we cancel? You're trying to cancel as much stuff as you can that's common to both sides. So I'm going to strike out all 7 of these waters, and I'm going to cancel all of them. So there's only going to be 2 waters left. So this is how I do it on my paper. I strike it out when I'm trying to get rid of it, and I just strike through the number and rewrite a number just above it. It's very much like algebra. When you're canceling like exponents or something, like x squareds, you might strike through the exponent or strike through the whole thing. So this is shorthand for me to tell me I've canceled all of these and I'm only left with 2 waters. So I look at the chromium 3+ ions, and I don't have any of those on the right-hand side. I look at 18 hydrogen ions, and I have 14 on this side. So you have to ask yourself, how many of these are common? Well, there's at least 14 common to both sides. So I'm going to strike through this, because that's now gone, and I'm going to strike through the 18. How many am I going to have left over? I'm only going to have 4 left over, because 18 minus 14 is 4, right? So that's it for that. Now this ion here, I don't have any of those on the right-hand side. So when we get to the cancel step down here, you see our problems have been getting more complicated. In the beginning, we just canceled electrons, then we cancel a little bit more. Some problems are going to have multiple things to cancel, so you have to look at everything. All right, so I think at this point we are ready to write the final solution of this guy. So what we're going to have is 2 chromium 3+ ions. All of this is gone. We have 4 hydrogen ions, right? And we have 3 of these ions, BiO3 negative. And on the right-hand side of the arrow, we have Cr2O7, right? This is gone. This is gone. So we have 3 bismuth 3 ions. And then we have only 2 waters. Okay, this is the final answer. So we have 2 chromium 3 ions plus 4 hydrogen ions plus 3 bismuth O3 ions plus Cr2O7 plus 3 bismuth 3 ions, and then 2 water molecules. So we are done. That is balanced. So you see the same process we're doing all the time. Basically, you make sure it's an ionic equation, split it up into half reactions, okay? Then you balance everything in the half reactions except for hydrogen and oxygen. Then you balance the oxygen with water. Then you balance the hydrogens with hydrogen ions. Then you look at the charge on the left and on the right-hand side like we did here, and we bring them into balance by adding electrons. Then we can multiply and add these reactions back together to get at something that we then cancel. We always know the electrons should cancel, 6 electrons, 6 electrons. There may also be other things that cancel like we've had in this problem. So what we need to do, or what I suggest that you do now, is check your work. You don't have to do this, but I recommend that you do it. First, let's check the balance of the elements. We have 2 chromiums, 4 hydrogens, 4 hydrogens, 3 bismuths, 3 bismuths, and here we have 9 oxygens. Here we have 7 here, and then we have 2 more. That makes 9 oxygens. So now let's check the charge, because in these redox reactions, that's half the battle, is balancing the charge transfer. So we're going to add up the charge on the left and on the right-hand side. So on the left-hand side, 2 times 3 is going to be a positive 6. Here's plus a 4, because positive 4. This is a negative 3, because each one's negative 1, so it's negative 3. So on the left-hand side, this is 10 minus 3, which is 7, positive 7. On the right-hand side, let's see what we have. What we have is negative 2, and then we have 3 times 3 is 9, and then we have 0, because water doesn't count for anything, it's neutral. So what we have is negative 2 plus 9 gives us positive 7. That balances the positive 7, so we know we have the right answer. At this point, you can just go to the next problem on your exam because you know you've gotten it right. If you have balanced everything, the elements are balanced, and the charge on the left and on the right-hand side are balanced, then you're done. It's like checking an equation in algebra. Once you've done that and you've checked it, then you've got the right answer, you can move on. And you can see it only took 2 seconds to check the problem. So do yourself a favor and do that. Make sure you understand this lesson. Work it yourself. Stop the video, go grab a piece of paper, write this reaction down again, and work the whole thing yourself. Believe me, there are so many steps here that it doesn't matter if you've seen it worked already. If you've seen me work it, you need to work it yourself. There's enough steps and enough logic. You're not going to remember the whole flow of this answer. So make sure that you get the right answer, and then follow me on to the next section. We'll get even more practice, and we're just going to make ourselves comfortable with this process. By the end of it, my goal is for you to pretty much have it memorized on what you need to do without struggling with memorizing it, but mostly by just watching and working through the problems yourself. Your brain will start to know what needs to be done, and these problems will become pretty easy.